Matt and Natalie. Thank you to Natalie and Donna and all the staff here for making GopherCon happen again this year. You know, running one of these is a lot of work, and I think we're all very grateful. So please join me in giving them a huge thank you. So, how many of you went through a lot of effort to get here today? You know, I think it's what, 50%? Well, to them, this has all be worthwhile. The whole conference is always a real pleasure. So I'm excited, and I hope you all are too. So as you all heard, I'm Cameron, and I am the product lead for Go at Google. I've been a PM on the Go team for 3 years now, and it's really been the highlight of my career. I get to work with some of the most talented people in the world, and then I get to see a dedicated community like all of you actually use Go to build these awesome products. And that community piece is really the best part of all of this. So thank you to all of you, and keep up the good work. Today, I'm going to tell you about the state of Go. And the short of it is, the state of Go is strong. But before I tell you why, I want to recount how we got here. Now, I wasn't there, but the story is that during a 45-minute C++ build sometime in 2007, Rob Pike and Rob Griesemer scribbled together a vision of what would ultimately become Go. According to Rob, a couple of Google employees had recently given a talk on all the new stuff that was coming out in C++ 11, and in the span of like an hour, Rob counted something like 35 new features that were being planned. And somewhere in there, he asked himself a question. Did the C++ committee really believe that what was wrong with C++ was that it didn't have enough features? Surely it would be a greater achievement to simplify the language rather than to add to it. And Rob made this observation in the midst of a period of tremendous growth at Google. The breadth of Google's products and services was growing, usage was growing, and the engineering teams at Google that built and maintained all that stuff was growing too. This slide shows us how Google's headcount grew between its IPO in 2003, when it had a little over 1,600 employees, to when Go 1.0 was released in 2012, when it had grown to over 50,000. So this meant a lot more people writing a lot more code, and then coordinating all of that carries all this additional overhead. And since Google's business is all about scale, this problem was only going to get worse. And this is where Go was born. Google was struggling with its scale. The complexity of a massive code base with so many developers working on the same products in Java and C++ led to brittle code and diminished productivity. And Go's vision was, hey, let's prioritize this scale, which means accounting for how modern software is architected, the environments in which modern workloads run, and probably most importantly, the teams that write, operate, and maintain all that stuff. So on that basis, from when Rob and Robert started in 2007 to when Go 1 was released in 2012, the Go team worked to define Go's founding principles and build it for release. This includes making it an open source project, which we did in 2009, and then ensuring that what we call Go 1.0 is usable, in part by putting it in production. Now, one of the key bits in Go 1's release notes was this sort of emphatically stated point. The driving motivation for Go 1 is stability for its users. People should be able to write Go programs and expect that they will continue to compile and run without change. So some programming languages are good at this, some aren't. We're going to be really good at this. In fact, we released Go 1 with a separate document that explains our compatibility guidelines in detail. It's the Go compatibility promise. And there we wrote, it is intended that programs written to the Go 1 specification will continue to compile and run correctly, unchanged for the lifetime of that specification. Go programs that work today should continue to work even as future point releases of Go 1 arise. And the reason the compatibility promise is so important is because what we sought to release in Go 1 was not just a programming language, but rather a platform for software engineering. The vision wasn't to sort of like come up with a new syntax or compete with C++ on the number of new features we could release. The vision was to facilitate real software engineering at scale. And that sort of software, it's written in teams, where members come and go, where there are deadlines, there are SLAs, all of that. And that sort of engineering really requires long-term predictability, not breaking existing code or sort of creating this perpetual maintenance burden. It also requires accounting for the fact that software development is more than just the programming language that you use. It's this multi-stage life cycle with different intersecting tools. And that's the idea of a platform. So in addition to the compatibility promise, Go 1 shipped with all this other stuff on the slide too, all of this out of the box. Instead of importing a third-party library for testing or like finding and agreeing on a style guide with your team, Go 1 started on this mission of providing our developers an entire platform for everything that you need to ship good, scalable software in teams. And in what ended up being another important decision, the stuff that came out of the box, it was all accessible from a single command. From the very start, Go was mindful of every link in the development chain, all the way up to the developer's command line. So with the Go command, we established the first, what we call a developer touch point, the entry sort of into our platform. And one that continues to be a very important means by which we're able to ship a unified end-to-end experience to this day. So that was version 1. Next, between 2012 and 2015, as developers were beginning to adopt Go, we focused our efforts on refining it. Like any software project, especially one of this magnitude, the first few versions had a ton of rough edges, and actual usage really helps you see that. And for Go, this was a multi-year process that culminated in 2015 with Go 1.5. So by 1.5, the platform was more or less refined. For example, the compiler and runtime were completely rewritten from C to Go. That's like this important rite of passage for a programming language of this sort, where the compiler is now written in the language that it compiles. The garbage collector was another sore point in the very first releases. It was just slow. But we introduced a new garbage collector in Go 1.5, which reduced overhead and pauses to levels that are similar to what you get in other garbage-collected runtimes. Stepping back to sort of the project level, it turned out that a predictable release schedule provided developers a lot of value because it allowed them to then plan their own releases around ours. So Go 1.5 is the first version where we committed to our semi-annual release cycle, and that persists to this day. And more generally, by Go 1.5, the standard library was hardened, runtime performance was improved, and various other things were fixed or improved throughout. But despite all this change, the compatibility promise from Go 1 applied. So as we wrote in those release notes, version 1.5 is a significant release, including major architectural changes to the implementation. Despite that, we expect almost all Go programs to continue to compile and run as before, because the release still maintains the Go 1 promise of compatibility. Now, we saw on the slide earlier that Go 1 had this primitive form of dependency management, but in 2018, modules were introduced, which really represented this fundamental shift in, 1, how Go code is written and packaged, and 2, how Go code, especially third-party libraries, was distributed. And what followed then was the ecosystem that sort of follows that. And so to this distribution point, before modules, you would go get your dependencies directly from their origin on GitHub or wherever else. And the introduction of modules alone didn't change that. But an important property of modules is that their contents for each version are immutable. And this provides opportunities for caching and authentication. So modules themselves were introduced in Go 1.11 and Go 1.12, along with the Go mod file, the Go mod command. And these things fundamentally changed how Go libraries are packaged and versioned. But in Go 1.13, we took advantage of that immutability property that I just mentioned to introduce the Go module mirror and checksum database. So now, with the module mirror, we could cache all these libraries because we know they're immutable, and because we know they're immutable, we can serve them much more efficiently, which makes dependency downloads faster, and then by caching them, we can protect you against some dependency disappearing from their original location later. And then separately, with the checksum database, we're able to store a hash of all the source code in all these dependencies, which allows us to detect whether the source at the origin has changed since we first saw it. And this protects against man-in-the-middle attacks and other forms of tampering with your dependencies. Now, the module mirror and checksum database, they don't tell you whether a dependency has a vulnerability to start, but by recording the hash the first time any Go user imports a dependency, we can detect whether the module changes on any subsequent import by any Go user anywhere. So in this way, the module mirror and checksum database, they're able to ensure that the bits that you or anyone else gets the first time are the very same bits that everyone gets on every subsequent time. And this capability, it started this new parallel consideration for our development efforts. We realized that as Go is growing, especially in these huge, important infrastructure projects, the importance of security was growing as well. So in addition to being a complete, refined platform for software engineering, Go also sought to be a secure platform for software engineering. So we talked about modules and the module mirror and the checksum database. Around the same time as that, we started to see a lot of really high-profile software supply chain attacks. The kind where an attacker could inject a vulnerability in a commonly used open source library and then affect huge swaths of a language ecosystem. You can think of Log4Shell in Java last year, for example. And that's where we really leaned into Go's security posture and capabilities. In Go 1.18, we introduced support for SBOMs, or software bill of materials. So this means that the Go compiler writes into every binary that it builds all the versions and dependencies in the source, which allows you to later verify that everything is correct with just the binary. In Go 1.18, we also introduced a built-in fuzzer, the first major programming language with native fuzz testing built into and integrated with its standard toolchain. You can think of fuzzing as this form of automated testing that intelligently manipulates inputs to your program to kind of flesh out bugs, particularly valuable for finding security vulnerabilities. Because of the module ecosystem, you can fuzz a specific version of a module, and if you discover a vulnerability, you can report the results of your fuzz test to the package maintainer, and the maintainer can reproduce your results guaranteed. And most recently, we've introduced into public preview our end-to-end vulnerability management system, which surfaces known vulnerabilities in your dependencies everywhere, from your IDE to runtime. This last one's ongoing, and it deserves a whole talk of its own, which Julie Q, our security team lead, who's in the audience, will really dig into in her talk tomorrow morning, and I'll touch on it a little later in my talk. All right, so now the introduction of modules and the security focus that followed, it all coincided with another important development. Go was becoming increasingly important in industry. For one, the entire cloud was being built on Go. This includes GCP, AWS, Azure, and all the important tools and services that were becoming this important core part of cloud-based software development. Enterprises began to adopt Go as well, using it for really important business-critical systems and infrastructure. I know some of you in the audience are from these enterprises and know this firsthand. Inside the Go team, all of this use and adoption led to this sort of acknowledgement of Go's criticality. A realization that attacks on Go can be particularly harmful, which validated our focus on security and made it even more important. So I mentioned that a lot of that security stuff came out in Go 1.18, but there was also this other really important non-security related change to Go 1.18, which is, of course, generics. Generics, all right. Generics were the single most requested feature of all time and the single most significant change ever made to the language. In the years leading up to the release of Go 1.18, there had been all this talk about doing this relatively larger overhaul that we'd call Go 2. And in fact, the compatibility promise I showed you earlier actually specifically carves out a possibility for a Go 2, one that would be potentially incompatible with Go 1. And leading into the work that eventually became Go 1.18, we realized this might be Go 2. Generics in particular, they're not only the biggest change we ever made to the language, they were likely the biggest change we will ever make to the language. But it wasn't Go 2, it was Go 1.18. And the question that always arose with that caveat in the compatibility promise was, well, when will Go 2 happen? And the answer is never, or it's already happened. There will not be a Go 2 that breaks Go 1 programs. Yeah, agreed. There'll be major revisions like what we saw in Go 1.5 and Go 1.18, but they'll never break your programs. Instead, we've doubled down on compatibility because it's far more valuable than any break from the past. In fact, we believe that prioritizing compatibility was the single most important design decision we made for Go 1. And as always, every release of Go has and will maintain the Go 1 promise of compatibility. And that brings us to today. Now, thinking back to that history that I laid out in the last section, you can imagine a series of layers that build on top of each other. The core stuff, like the language, the compiler, runtime, standard library, they were all introduced in Go 1. Modules were this paradigm shift that began in Go 1.11. And then our latest security focus, that stuff that goes beyond modules, it really begins at Go 1.18, where we introduced SBOMs and fuzzing, and now we're on a vulnerability management. The next important piece to consider is how we continue to provide a platform. So, earlier I emphasized the significance of the Go command in Go 1, that it's this developer touch point and the means by which we're able to ship a unified end-to-end experience. But along the way, we expanded into other important developer interfaces that enable us to really expand our definition of what it means to be a platform. The Go command itself, of course, that's the original, the one you get at the command line. But our web properties, go.dev, package.go.dev, they enable us to provide a rich experience for ecosystem discovery and documentation. For example, we recently added vulnerability data to our package site, which bolsters the ways in which we're able to deliver security-related information to Go developers and at more stages of the software development lifecycle. And more recently, in 2020, we took over ownership of the Go plugin for Visual Studio Code. So this allows us to consider how developers can use the things that we build at the very earliest stage of the lifecycle, of the work process, in the IDE itself. So when we release generics in Go 1.18, for example, we're able to ensure on day one that generics are available in the IDE. And vulnerability data was recently integrated there as well, which Julie will tell you a lot about. So that's the platform as it exists today. This is its adoption. So let me start by saying that there's a lot of different ways to measure or estimate how many Go developers there are, and it's really difficult to land on one particular way of doing this. So in this case, what I've done is I've taken the proportion of respondents who report using Go on Stack Overflow's annual survey, developer survey, and then I multiplied it by /Data's estimate of the number of developers worldwide in each year. And when we do that, the state of Go looks really strong. We had 3 times the number of developers in 2022 as we did in 2018. And between 2021 and 2022, we took on 1.2 million new developers. That's a lot of new developers. And I'll return to that observation later. Existing developers are extremely satisfied as well. So not only are we growing well, but once developers use Go, they seem to be overwhelmingly satisfied with their experience. This is important, not just because it validates our work or bodes well for future adoption and retention. It also means a lot for team happiness, culture, and recruiting and retaining talent. Part of that core mission of optimizing for software that's built in teams. And we think there will be a lot more of this to come. Go is consistently in the top languages developers want and plan to use, and 2023 is no different. This slide from earlier this year shows that more developers say they plan to start using Go in the next 12 months than any other language. We're sort of used to hearing this sort of thing by now, but it's really remarkable, and it's a fantastic leading indicator of what's to come. Which brings us to how we think of Go today, and the work that we're doing now, and how we'll continue to pursue that core vision that started this project in the first place. All those things we learned in the last 13 years, the things we focused on, the impact we had, it all sort of reduces to the mission and the title of this slide. Go provides the most productive platform for building production systems. It's productive because it's easy to learn and maintain and scale across teams. It's a platform because it's more than a language, it's an end-to-end developer experience. And it's production ready because it's reliable, efficient, stable, and secure. This is the framework that we use to think ahead. And with that, where we're going next. So first is the work we have underway for making Go more productive. We released generics last year in Go 1.18, but we continue to improve on it now, including in the standard library. We're also making these sort of ergonomic changes to the language itself, including a long-sought proposed change to loop variable semantics and another for standardized iteration. We're improving onboarding. As I said earlier, we take on a lot of new developers. From that Stack Overflow number I showed you, more than a third of Go developers just started using Go in the last year. And as we saw on the slide from earlier this year, more developers say they plan to start using Go this year than any other language. So we need to think of these developers and their experience so they can quickly get started and be productive, and then also be productive after that. And I should say, we really think of onboarding very broadly here. You can even think of things like error messages, linking, documentation improvements, all those things. They improve onboarding. And these things help new users be productive, but an important side effect is that when we help these new users be more productive, we almost always help all users be more productive, including all of you. Next, we continue to think of complete, cohesive solutions that reach all of our developer surfaces. Remember, it's not just a language, it's an experience. For example, this year, we're planning to survey package maintainers to understand what we can do to better support the package ecosystem. And package ecosystem is a huge part of what makes Go powerful today. We also continue to make our developer touchpoints more useful and robust. We recently made a lot of really important scalability improvements to Go Please, our language server, which will make every IDE that relies on it substantially faster, especially for larger code bases. And our VS Code plugin continues to get better and more integrated, including by integrating with our new vulnerability management system. So I've said vulnerability management a bunch, and I said Julie will talk to it, but what is it anyway? The short of it is that the Go team has created a comprehensive data source of all known vulnerabilities in the Go ecosystem, which we've done by pulling vulnerability data from a variety of places, like the GitHub Securities Advisories database and direct reports from Go package maintainers. Vulnerabilities from all these data sources are individually reviewed, curated, and then aggregated into the Go vulnerability database. And probably most importantly, we've made all of this data easy to find and use, most of all by integrating it across all of our developer touchpoints. So you can learn about the ones that might affect your dependencies on our package site, say before you choose to use a dependency. And you can use our command line tool to check at the command line or at CI. You can detect and fix vulnerabilities in your IDE through our integration with VS Code. And this is like the latest example of how, by focusing on building a platform, we're able to create these end-to-end solutions at all stages of the software development lifecycle. Finally, we continue to make Go production ready. Performance and reliability are a huge reason developers choose Go, and we want to be sure that we're still leading the way. So having doubled down on compatibility, we've taken steps towards ensuring that you can, if needed, emulate behavior from older versions of Go. So if the loop variable fix I mentioned surfaces a bug in how your code uses loop variables, we'll make it possible to force compatibility so you won't have to worry about upgrading or breaking when you upgrade. On the performance debugging and monitoring side, we're exposing more metrics for the garbage collector. We're writing a garbage collector guide. We're working on execution tracing and ensuring that Go works better with the Linux perf tool. And our standard library is seeing some really important new functionality as well, like structured logging, which Jonathan Amsterdam from the Go team will talk about in depth tomorrow. All right, and that brings us to the last section. Even if we're doing all of this work to make Go the most productive platform for production systems, why do we think we'll succeed? Well, the answer is actually right here. It's Go's community. Since I started on the Go team a few years back, there is really nothing that has impressed me more than the community and the culture that you all have built here. The Go project itself, not even counting the ecosystem, is a vibrant and growing community of developers from all over the world who vote, comment, and contribute, to this enduring sort of project. There is a large, robust library ecosystem as well. almost 1 million different modules. This is one of the most important things we have and what we need more of. Quality libraries make everyone more productive, and they unlock these new opportunities that we as the Go team could never foresee. And we see Go really thriving in open source, which really bodes well as a leading indicator of what we think we'll see in industry next. So, programming language adoption, especially when you view it in the aggregate, it's fundamentally slow. A lot of stuff has already been written, and developers continue to maintain or improve on it. And it'd be really inefficient for these developers to sort of just rewrite these workloads in a new language. Nobody wants to fix what isn't broken, and we don't want that either. Our objective, kind of our opportunity, it's to target new applications. So on this slide, we plot out the proportion of pull requests on GitHub by language per quarter for each of the major statically compiled memory-safe languages, C#, Java, Rust, and Go. It isn't aggregated over like the last 20 years like you find in a lot of benchmarks or like surveys that'll say what languages you use. This is a quarter-by-quarter breakdown, sort of like a first derivative. And it's of actual work, measured in pull requests. And as you can see, Go's ascent in red here, it's really pronounced. In the last few quarters, it's practically tied Java. And that's really so exciting for 2 reasons. First, because Go is growing in open source, it means there will be a lot more libraries for developers to use, furthering that flywheel of productivity for all Go developers, and furthering that vision of a really productive, secure platform for production systems. And even more than that, it means that Go and the Go community are really well positioned for the future, ready for those big shifts in technology that happen from time to time. Go and the Go ecosystem are better than ever. They're ready for those moments when new code is written. But for all of that success and excitement, it always comes back to you, the community. We all know that there's millions of developers actively using Go to build their applications, and we know there's going to be a lot more to come. But even more important than that, there are hundreds of thousands of Gophers around the world who meet up, they come to conferences like this because they love Go. And that's irreplaceable. That, most of all, is why the state of Go is strong. And that's it. Thank you, and let's have a fantastic conference.